Welcome back everybody. Part 14 here in our series on how to build a single-ended tube amplifier. And what I've learned along the way here is we continue to iterate on this thing. And that's typically the way these DIY projects go, to be fairly honest. You kind of get an idea and you go at it, and then you learn a few things along the way and you adjust. And as you may have noticed, I have completely moved these chokes. Just the interaction with the output transformers was scaring me a little bit. Although I will say the bottle head, Stereomore, and I think one other model both do that. They mount the chokes right below the chassis, and they even use the same mounting holes over on the top side to mount the output transformers, and they seem to work okay. But it was an interesting video that Mr. Carlson did here recently. I was watching last night on he uses this thing he designed called a super probe. It's basically a little probe that picks up any kind of noise, RFI, EMI, or just stray magnetic fields or whatnot. And he was using it in an amplifier where the choke had been mounted right below the output transformers, and he was able to prove and show where he actually had introduced noise into the output transformers. So a couple things we did this morning. I took these two things off of where they were over here, the two chokes, and I basically moved them up here. I used an existing mounting hole in this transformer, this hole was already here, and then I just had to drill this one hole right here to kind of mount this one. And I've rerouted this filament wire just a little bit. And then the only other thing I did was I used a terminal strip here and mounted between these two lugs on this side. And I did a similar thing on this side, except for I didn't have another 8 lug with 2 and 7 being center, so I ended up with a 8 lug with the outer 2 being the connection, so I had to drill one more little hole over here, but no big deal. And we've got that mounted in at this point, and this makes it for a great place for this filter cap over here on this side, and I'll end up being able to put the other power supply caps on this strip over here, and we'll kind of keep all the power supply here kind of in the back half of this thing. So I think we've got a better chance now of not having any kind of interaction between these chokes, because they do put off quite a bit of magnetic flux, and we'll see how this goes. So let's dive into talking about running this bus wire a little bit. So the focus of today's video is really wiring up the power supply and this ground bus. Okay, I got my little bus wire here that I'm going to start soldering in. Just cut it off, not right to length, but kind of getting the idea. I'm going to mount this capacitor back here. But one thing I'm going to be using here to kind of keep this bus up above ground is these little things. And I don't know where I got these. I picked them up at a Hamfest or somewhere, but I'm pretty sure you could find them online. It's basically a terminal strip, but instead of having little loops on the end, it has these little prongs that stick up fairly tall here. So I've mounted one here. I'm going to end up mounting one down on this end, and it kind of lets me run this bus wire along at a level a little bit higher than the rest of what you would get with a normal terminal strip. Okay, really happy how this bus is going to turn out here. As you can see, I started back here with the negative of the very first capacitor here. Going to run along, going to come all the way up here, and I'm going to come across, and this is going to be for the preamplifier tubes here. And then this bus point here is going to be for the power tube. So if you think about it, the way we talked about in the other video was you always want to kind of start with your capacitor here. You're going to want to work your way downwards. You're going to want to kind of come across and pick up your power tubes first. So those would be, well, you finish the power supply, then you're going to want to get into your power tubes, then you're going to want to get down to your, so serial wise on this bus, this works out just fine. And I think these things look beautiful, nice and strong and sturdy in there, and looking good. Okay, and I realized I was going to have to run You can see it here. Some capacitors off of this tag board over here as part of the power supply. So I went ahead and ran a bus bar over, and I tied it to these first two, or second and third tabs right here. So it's on there good and strong. All I've got left is solder this thing into this capacitor, but gives it a nice little look there, all squared up and kind of true. I'm liking it. Okay, first thing we're going to wire up here is, as you can see here, want to get the power transformer all wired up. So we noticed that two of these are going to go to the plates on this 5U4, both pins 4 and 6, the outer two windings, and then the center tap is going to come over here and tie to the what we're going to call our star point. This right here will end up being our very first star point. So let's get that wired up. If we look here on the schematic, or the wiring diagram here for this output transformer, it'll be the red and the red, which will give us 710 volt center tap, and then the red yellow will be the one going to the star point. Okay, as you can see now, we've wired up number 4 and number 6 here on the plates of this rectifier coming off the high voltage here. We've taken this center tap and we brought it over here. I cut that strip tie and added a new one on there. I brought it over here and I tied it on to my ground here. If you'll notice, I've also tied between this bus here and down to this tab, which is actually grounded here to the chassis. So this being my star point, I'm probably going to tie between these two right here to give myself just a few more soldering points and whatnot. But that's the first point in the star bus. This thing is starting to wire up well. Getting rid of all the clutter we had up here with all those wires earlier, if you'll remember. Okay, we've got the first cap now wired in, this 33 right here, and it, all this is sitting at 450 volts, and unfortunately right now all I have is a 450 volt capacitor. I ordered some 500, and I don't know why I didn't have them on hand, but as soon as I get that in, I'll replace it. The good news is I've got a bag of about 40 of these, so if this thing doesn't like the load until then, I can easily replace it, but I'll end up replacing that with a 500 volt. And what I did was the first point off of that, now we've wired one leg here of this choke, and we've wired one leg of this choke, and I've also came off of pin number 2 here and came around with a wire to it. So if you'll notice here off of pin 2, you've got a wire that kind of comes across, and I'm just kind of marking these things out as I solder them in. I've also got the 10 Henry connection here going to this choke, and the 10 Henry connection going to this choke right here. That'll go in there, and I'm also going to have to figure out this the floating here of the actual capacitor. Actually, instead of floating it right here, I actually think I'm going to float it down here, because this would even be more rectified than back here. So I'll end up taking this tag point here and bringing it over right here. So we're going to keep grinding along and get this whole power supply wired up. Okay, we've wired the other two sides of the chokes, one over here to the bottom of this cap here, and the other side to the other cap bottom here. So, or the positive of both of these, that's the negative. So that kind of gets out of the way both of these connections right here at this point. Both of these caps are soldered in at this point, because these two are this can cap here. This one here is the very first one here. So now we just got to do some jumpering with some 8.2K, 2 watts, and then we got to drop in 22 microfarads, and I'm going to end up doing that on this side. So we're going to come off the high voltage over here, feed across over here, and turn this terminal strip here into the rest of this right here. Okay, just been working on a couple things. I've got my two 8.2K resistors kind of tagged in right here, and I've been making a series of these. These are the two 22 microfarad at 450 volts, and then the two 10 microfarads at 400 volts. And I'm just kind of, and I've taken this whole bar underneath here and extended it, so this bus now goes all the way down to right here. So that's kind of the common ground all the way down there on the bottom, which ties back over here to that first cap, which goes to our first star point. Okay, I've got to do some jumpering between these various top pieces of the positives of these capacitors. I got to go from here to here and here to here. So I'm going to, with these 10K resistors, so I'm going to use some of the Teflon PTFE wire cover that should slide right on there just like that and keep anything from touching each other. Very first cap here feeds down to ground, which is our star bus point, and then the other side of it is where I've got the two chokes at and whatnot. So then we feed into one side of the choke and then the other side of the choke, and we kind of come out both sides of the other side of the choke to the 450 volt point, which is actually the top of these capacitors here, which happens to be these two lugs down here on the bottom. This top lug here is the common ground for this capacitor. And then coming off of it, if you'll notice, I've got an 8.2K and an 8.2K, which is actually our 350 volt spot. And then I've got a red and white wire that runs from there and a red and white wire that runs from here all the way over, and it tags right here and right here. And it goes to the top of this capacitor here, 22, which goes to ground. And then the other one goes to the top of this capacitor, and the bottom of this is tied to that bus that's all tied in. It's the same piece of wire here. So we're going to ground here and ground here. And then we've got from the top of this capacitor right here, we've got to have a 10K 1 watt resistor, and I just use 10K 2 watt. That feeds over to the top of a 10 microfarad. So that's what I did here. I fed across into the top of this 10 microfarad, and the other side of the 10 microfarad is tied to that bus, and the same with this 10K resistor down tied to this one. So we've kind of got left, right, left, right, left, right here for all of these scenarios. And so this is our 300 volt points. This is our 350 volt points right here. And then back over here, this point and this point right here are our 250 volt point lead-offs. So really all I've got left in the power supply now is to wire up this little the heater voltage elevation here, what we're going to do. So it looks like I'm going to have to put 2 resistors and a capacitor, so I may want another little tag strip somewhere for that. Okay, I've been studying a little bit on what I wanted to do here. I'm going to take the green with yellow, which is the center tap for the 6.3 volt winding, and I'm going to bring it over here, and I've got an empty tab right here that's not being used by anything, and it happens to be near the ground bus right here at the first star point. So I'm going to bring it over and I'm going to tie this wire right here into it. And then from there, I'm going to tie between that point and this bus ground with my 160 volt, 100 microfarad, I think that's a Nippon, it is, cap. And I'll tie it in here like this and tie one end up here on the bus. And then all I've got to do is parallel that with my little 82K ohm resistor. And then I just have to go between there and the 10 Henry point where those come together, which by the way happens to be right here. So it'll be simple enough to run a resistor up and over to there, and we'll have all that wired up. Okay, we've kind of got it all wired in now. We've got this 160 microfarad cap between ground and this first point right here. Between that first point right there, we've got a 390K ohm resistor that goes over to where the 2 choke points come off of the top of this cap right here. So that's exactly what it should be, this 390K. I went ahead and decided to tie it right here. And then we should have that capacitor going to ground and an 82K, and between there and ground up here I've tied this 82K. So it's all tied in there nice and neat. My tough part's going to be replacing this 450 volt cap with a 500. The 400 may work just fine because this thing actually runs at about 440 volts. It's just not what I would want for long term. Matter of fact, it ran fine with this when we had it built on the breadboard on the bench here, but long term I want to put a bigger cap in there. And as you can see, everything tied up, strip that off. I keep adding wires to that bundle. Okay, we're going to bring this thing up on the bench now, and I've got this wire connected to the top of the first 33 microfarad cap, which should be about 450 volts. And I've also got this connected to the bus ground. I've got this tied across the heater windings here. And if you'll notice, we're getting about 5.9 volts here on the heaters, which should be about 6.3. And we've got 400 and what we got here, 35 volts. And the reason that is I've got it on a variac and I've got it turned down just a little bit. I don't want to run this thing up over 450 volts because that's kind of what that cap's rated at. So I was just going to, until I get that new cap in, I was just going to kind of run the variac here and keep this thing down around 440 volts, which keeps this at about 6 volts over here, as you can see. And if I flip this over, then let's see, I should be able to go then between the bus and go to volts DC. And look at that, we're sitting at about 75 volts above ground DC. And that's this whole floating heater scenario that we've created right here where we floated the center tap. So it makes this voltage floating above ground the way we had anticipated. Got the rectifier tube underneath and it's nice and heated up at this point. And then, well, let's check a couple of the other voltages along the way. If I come over here and check, I should be, let's see, that's at 441 volts there. And then as I come along and kind of jump to a few different places, 440 volts. The challenge is I don't have a load on the other side of these capacitors yet, so there's nothing to pull the voltage down. So they're kind of floating all up at a very similar place right now. But the good news is it's working and working as designed. And I'm pretty darn happy with how it's turned out right now. I'm going to turn that variac down. It keeps climbing up a little bit as this power supply steadies off. Keep it around 440 volts right there and we'll play with it. But the good news is the power supply is good and solid. Sometimes when you turn these on for the first time, this thermistor right here, as they heat up, you'll smell them a little bit, but it should go away within a minute or two. In general, though, pretty happy with how this thing's turned out, and the power supply seems to be nice and clean. I may throw a scope on this and just see what kind of readings I get. Okay, we've got it running there about 436 volts, and I've kind of just hooked a scope up to the same lead. Nice, clean DC signal, flat as could be. Not much noise, if any at all. Really happy with how this thing's turning out. I'm going to wrap this up. This is the grounding and the power supply build, and then hey, there's not a ton left after this. Maybe another video or two and we'll have this thing wrapped up, and I'm going to work on at least one of those today. Thanks for watching, everybody. Stay tuned.